Welcome to Across the Globe. Today we will learn about functions in Go. Functions in Go are essential units of code designed to execute specific actions. They are created using the func keyword alongside the function name and any necessary parameters. These functions can both take input parameters and produce return values to facilitate communication with other parts of the program. A notable feature of functions in Go is their ability to call themselves recursively, allowing for efficient and concise code execution. For instance, a factorial function can recursively call itself to calculate factorial values. This feature is particularly useful while solving problems that involve repetitive tasks or computations. The provided code defines a function add that takes two integer parameters a and b and returns their sum. In the main function, add is called with arguments 5 and 3, and the result is stored in sum, which is then printed. For example, in an e-commerce system, a function like add can be used to calculate the total price of items in a shopping cart by adding up individual item prices. The main function could then display the total price to the customer. This type of modular approach to coding allows for reusability of functions like add across different parts of a program, promoting efficiency and maintainability in software development. In Go, functions can be passed as arguments to other functions, allowing for the creation of higher-order functions. This feature enhances the flexibility and power of the language by enabling functions to be treated as values. For example, a sort function can take a custom comparison function as an argument, giving the user the ability to define their own sorting criteria. Another scenario where this is useful is callback functions, where a function is passed as an argument to be executed at a specific point in another function's execution. This capability greatly expands the range of problem-solving techniques that can be employed in Go programming. The given code defines a function named add that takes two parameters and returns their sum. Another function named apply operation is defined to take a function, like add, along with two values, and returns the result of applying the function to those values. Finally, the apply operation function is called with the add function and values 5 and 3, resulting in the output 8 when executed. For example, this code structure can be useful in scenarios where different operations need to be applied dynamically based on certain conditions, such as calculating discounts in an e-commerce system or processing various types of data in a data analysis tool. Anonymous functions, or lambda functions, in Go are functions defined without a name and can be created inline. They are commonly used for implementing callbacks or function parameters. For example, to sort a slice of integers in descending order, you can use an anonymous function with the sort.slice function. This function takes a slice of data and a custom comparison function as arguments, which can be an anonymous function that specifies the sorting logic. This allows for concise and flexible code, especially in situations where defining a separate named function would be cumbersome. The provided code snippet demonstrates the concept of anonymous functions in Go. Within the main function, an anonymous function is declared and assigned to the variable add. This anonymous function takes two integer parameters a and b and returns their sum by returning a plus b. Subsequently, the add function is invoked with arguments 5 and 3, resulting in 8. The computed result is then printed to the console using fmt.println. Anonymous functions are particularly useful in scenarios where a function is required for a limited scope and reusability is not a concern. In this case, add serves as a simple addition function that is only relevant within the main function. Overall, anonymous functions provide flexibility and convenience, allowing for concise coding in certain situations. Functions in Go are like recipes in a cookbook. Just like a recipe tells you step-by-step how to make a dish, a function in Go tells the computer step-by-step what to do. Each function has its own name and set of instructions, just like each recipe has its own title and list of ingredients. By calling a function, you are telling the computer to execute those specific set of instructions, just like following a recipe to cook a dish. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet demonstrates the use of functions in Go programming language. The add function takes in two integer parameters a and b, calculates their sum using the plus operator, and returns the result. This function provides a reusable way to perform addition operations in the program. The greet function, on the other hand, takes a string parameter name and prints a greeting message, "Hello, name." This function can be used to greet different individuals by passing their names as arguments. In the main function, the add function is invoked with arguments 5 and 3. The result of the addition operation is stored in the result variable and printed to the console using fmt.println. Next, the greet function is called with the string argument Alice, which prints "Hello Alice" to the console. By utilizing functions like add and greet, the code promotes modularity, reusability, and readability. This enables developers to efficiently organize code, reduce redundancy, and enhance maintainability. Upon running the program, the output displayed will be sum of 5 and 3 is 8. Hello, Alice. Real-world applications of functions in Go include creating modular and reusable code structures, implementing business logic in web applications, handling data processing tasks, and performing complex mathematical computations. Functions in Go are versatile and widely used in various industrial applications. Let's discuss two examples. One, finance industry. In the finance sector, functions in Go are utilized for complex calculations and processing large data sets. For instance, a financial institution may develop a Go program that uses functions to calculate risk assessment metrics, analyze market trends, or perform algorithmic trading. These functions help in efficiently processing financial data, making informed decisions, and managing investments effectively. 2. Cloud computing. Functions play a significant role in cloud computing platforms where scalability, reliability, and performance are critical. Cloud providers like AWS, Google Cloud, and Azure leverage Go functions to handle serverless computing, or FaaS, function as a service. Developers write functions that respond to events, process data, and perform specific tasks within a cloud environment. This allows for flexible and cost-effective scaling of applications based on demand. In conclusion, functions in Go are indispensable in real-world applications across diverse industries, enabling developers to write modular, reusable code for complex tasks and efficient operations. Keep learning, stay curious, and I'll catch you in the next video.